everyone, welcome to the Scale Drawings Guided Notes. To get started, we're going to talk a little bit about what are scale drawings. It says drawing the actual size of many objects such as a house is not possible. Therefore, scale drawings are used to represent actual objects on paper. Scale drawings in the real world. What types of careers involve using scale drawings? So you'll see lots of scale drawings used with architects, with engineers, with drafters, with artists. Scale drawings are drawn with all measurements proportional to the actual size. Scale drawings always include a scale so that you know the proportions used. Let's look at the drawing of this house right here. Why could this not be a drawing of an actual house in terms of proportions? So if we look at this house, there might be various things why this couldn't be an actual house, but let's look at example for the door. The door is as wide as about 1.5 times this house. So either that's a really, really big door or that's a very, very skinny house. If the units are different, a scale may look something like this. 1 inch to 4 feet. So this is an example right here of a scale. This means that 1 inch on the scaled drawing is represented by 4 feet on the actual object. Note that the dimensions on the scaled drawing come first in the ratio, and this may be something you want to highlight or circle or put a star by just to make note of. If the units are the same, such as 1 feet to 5 feet, this is often written as 1 to 5. This means that 1 unit on the scaled drawing is represented by 5 units on the actual object. Okay, now we're going to look at lengths and areas with scales. Let's look at the scale drawing of a stop sign. So we're looking at this stop sign right here. The scale used for this drawing is 1 inch to 25 centimeters. This scale means that every 1 inch on the drawing is represented by 25 centimeters on an actual stop sign. Let's calculate. This drawing is, and then it says blank inches tall. So get out your ruler and we're going to measure the height of this stop sign. So I have my ruler right here. And let's measure it. It looks like it is going to be 3 inches tall. We can determine the actual height of a stop sign by creating and solving a proportion. So we know the drawing's 3 inches tall and we know the ratio is 1 inch to 25 centimeters. Now we're going to figure out the actual height of a real stop sign. There are various ways to set up a proportion as long as the units and connected information are aligned. Let's look at some proportions that will work for determining the height of the stop sign. We have this right here. So notice we have centimeters going across and inches on the bottom. Then on the side we have the given scale and the actual size. The given scale in centimeters is 25 centimeters, 1 inch, and then the centimeters X, like we don't know the actual height in centimeters of the stop sign, but we know that the height of the stop sign drawing is 3 inches. So notice how this information all connects, all the proportion. Or we could set it up like this. We could have the given scale here, the actual size on the bottom, the inches on the sides, and the centimeters on the side. Let's set it up if we were going to do it like that. So my given scale centimeters is 25. The given scale in inches is 1. My stop sign drawing is 3 inches tall, and I don't know the actual size. So see how these proportions, they're set up different in the way that where everything is on the proportion, but everything is connected either horizontally or vertically. If we look at this proportion below, this one will not work. If you notice, my scale is going diagonally, and my actual size is going diagonally. That's not going to work. Even though my centimeters are here set up vertically and my inches are set up here vertically, everything else is set up diagonally, so that's not going to work. All right, now it asks us to figure out the actual height of the stop sign. We're just going to go up to this proportion right here and solve it. With proportions, I can either look for multiplicative relationships horizontally or vertically, or I could also solve it like an equation. Right here, I do notice a multiplicative relationship going across. If I multiply 1 times 3, I get 3. So I'm going to do the same thing on the top, multiply 25 by 3, and I'm going to get 75, and my units will be centimeters. And then for explain your reasoning, I said using the first proportion, my second ratio is 3 times the first ratio. Let's look at this school crossing scale drawing right there, that sign. The scale used on this drawing is 1 inch to 20 inches. Since the units are the same, we could also write 1 to 20. And then it wants us to figure out the width of the scale drawing. So remember that 1 to 20 means 1 inch on the sign, like maybe 1 inch would be 20 inches in real life. So I need to set up a proportion. Let's use my scale here on the left. I'll say 1 to 20. So this is my scale. Now remember, I could set that up differently as long as it's either going horizontal or vertical. And now I need to figure out my actual height. So I'm going to measure here with my ruler, and we'll figure out what is this width of this on my drawing. All right, so if I'm going to measure here, it looks like my drawing is 1.5 inches long. So the width of the scale drawing is 1.5 inches. Write a proportion to help you determine the width of the actual sign. So going across here, my top is going to be the drawing. My actual width of the drawing is 1.5 inches. I'm trying to figure out the actual width of the sign, so that's going to be my variable, and we'll use x. So then the width of the actual sign is, so now we need to look for either multiplicative relationships or solve it like an equation. But I notice right here, 1 times 20 will give me 20. So 1.5 times 20, which is 30, will give me the width of the actual sign. Says, consider this yield sign to be a triangle. The scale used is 1 inch to 15 inches. Let's mark that. Using the scale, calculate the area of the actual yield sign. To determine the area, we will need to determine the... Okay, so for area of a triangle, we need to determine the height and width of the actual sign. Okay, on this drawing, it actually gives me the dimensions, so I don't need to measure. It tells me that the width of the triangle is 2 inches and the height is 1.73 inches. I'm going to need to set up 2 proportions here, 1 for height and 1 for width. So I need to set up my scale either horizontally or vertically in my proportion. I'm going to go ahead and set it up vertically here on the side, and we'll do the same thing for width. And then we'll do the drawing on the top, since that's what I have for my scale. So I have the scale drawing on the top, and then I'll have the actual on the bottom. So the height of this scale drawing is 1.73, and the width of the scale drawing is 2. And then I'm trying to figure out the height of the real yield sign and then the width of the real yield sign. Okay, I'm going to look either for a multiplicative relationship or solve it like an equation. I notice here on the height, going from the numerator to the denominator, I can multiply by 15. So I'm going to take 1.73 and multiply by 15. And that's going to give me 25.95. Looking at the width, again, I can notice the same thing. I can multiply right here by 15. So I multiply 2 by 15, and that's going to give me 30. Now I know the height and width of the real yield sign, so I can figure out the area. So I'm going to multiply 25.95 times that by 30, and I'm going to divide that by 2 since it's a triangle, and that's going to give me 389.25 square inches. Let's do some more practice problems for finding area. The scale used for this triangle is 2 centimeters to 5 feet. So remember, that means 2 centimeters on the drawing is 5 feet in real life. Determine the height and area of the actual triangle. Okay, so we need to figure out the height and the area. But if we need to figure out the area, we're also going to need to figure out the width of the actual triangle to figure out the area. So we're going to set up two proportions, one for the height and one for the width. Again, I'm just going to put my scale here on the left. I don't have to put it there. I can put it across. I can put it on the right as long as I am consistent. So it's going to be 2 centimeters to 5 feet on both of those. And then on the top, I have my drawing. So remember, 2 centimeters on the drawing is 5 feet in real life. So my height on the drawing is 4 centimeters. So I'll write that here. And then my width on the drawing is 6. And then my unknown is the actual height and the actual width. Now we'll look for a multiplicative relationship, either horizontally or vertical, or solve it like an equation. I notice here on my height proportion that I can multiply by 2. So I'm going to multiply 5 by 2. That's going to give me 10. So the actual height of the triangle is 10 feet. On my width, I can multiply by 3. So the actual width of the triangle is 15 feet. So the height of the actual triangle is 10 feet. The area of the actual triangle, so area we need to figure out. So area of a triangle is base times height divided by 2. And that's going to give me 5 times 15, which is 75 feet squared. Now we're going to look at this rectangle. It says the scale used for this rectangle is 1 to 12. Determine the height and area of the actual rectangle. Okay, so for the area of a rectangle, again, I'm going to need to know the height and the width. So I'm going to set up two proportions, one for the height and then one for the width. I'm going to do this one differently just so you can see how it works. I'm going to put my scale going across. It's going to be the same concept though. So my scale is 1 to 12 on both of them. And then going down, I'll have what it is on the drawing. So 1 on the drawing is, we have 2.5 for the height, and then the width is 8. And then my unknown is the actual height, and then the actual width. So I'm going to look for multiplicative relationships if I can. I notice 1 times 12 is 12, so 2.5 times 12. So the actual height is 30 inches. And then going the same thing with the width, I can multiply by 12 here. So 8 times 12, and that's going to give me 96. So to find the area of the rectangle, it's going to be the base times the height. So 96 times 30, and that gives me 2,880 inches squared. So the height of the actual rectangle is 30 inches. And the area of the actual rectangle is 2,880 inches squared. Okay, down here on the bottom, we have a little bit of a different shape. It says the scale used for this figure is 2 inches to 7 feet. So 2 inches on the drawing represents 7 feet in real life. Let's mark that. Determine the height and area of the actual figure. So again, if we kind of divide this up here, I notice I have rectangle and then a triangle. So to find the area of that, I'm going to need to know the area of this rectangle and then the area, so this rectangle right here, and then the area of this triangle here at the top. So let's just focus on the rectangle right now. We'll set up two proportions, figuring out the height and width of the rectangle in real life. Again, I can put my scale either across or up and down. Let's do it across again. So my scale is 2 to 7, 2 inches to 7 feet. And then the drawing I have here on the left, because that's my first number of my scale. So my height of my rectangle on my drawing is 4 inches. And then the width of the rectangle on the drawing is 12. So we'll look for multiplicative relationships, either going across or vertically. I notice going vertically here, it's times by 2. So 7 times 2 is going to give me 14. Up and down here, I'm going to multiply by 6. So 7 times 6 is 42. So the area of the rectangle is going to be 14 times 42, and that gives me 588 square feet. Now I need to look at this triangle. Notice right here, I need to figure out the base and the height of the triangle in real life to figure out the area of it. I actually already know this right here because that is the same as this, right? So this is going to be for my triangle as well. Do you see that? So the base of my triangle in real life is going to be 14, and I'm just going to write that here on my triangle. So I just need to figure out the height of the triangle. So let's set up a proportion for that. So I'll put my scale here going across. So that is 2 to 7, 2 inches to 7 feet. My first number is going to be my drawing. So on the drawing, 3 inches, and I need to figure out is how many feet. Okay, you may notice the multiplicative relationship of multiplying by 1.5 there, but if you don't, let's just solve this as an equation. I'm going to flip my numerators and my denominators on both of them to get my x here in the numerator. And then I need to get rid of the 7, so I'm going to multiply each side by 7, and I'll figure out x. So x equals 7 times 3 divided by 2, and that is going to give me 10.5. All right, so this is 10.5 right there. Now let's go back and answer the questions. It says the height of the actual figure. So the height right here, and I just figured that out before, and that's going to be 14 feet. The area of the actual figure. So I know that my rectangle here is 580. I need to figure out the triangle area, and so I'm going to go base times height divided by 2. So it's going to be 14 times 10.5 divided by 2. That's going to give me 73.5. So now I need to add 588 plus 73.5. That's going to give me 661.5 square feet. Okay, now we get to actually draw. We are going to draw a scale drawing using the scale 3 to 1. This means that every 3 that you draw represents 1 on the original. Since the scale is 3 to 1, you can multiply every measurement by 3 to get your new measurement. 3 will be called the scale factor. So this right here is my original, and I'm going to do, so that's my second number, and I'm going to do the drawing. So just think a minute if it's going to get bigger or smaller. So every 3 that I draw on my drawing represents 1 here. So that's actually going to make it bigger, right? Because I'm going to be drawing 3 of every 1. I need to draw this scaled triangle below. I'm going to scale it using the scale factor of 3 to 1. So let's go ahead and measure it. So get out your ruler. We're going to measure the height. The height is 1 inch. Let's just label that. And then the width, let's go ahead and measure. And it looks like the width is 2. So let's label that as well. So going back to this, since the scale is 3 to 1, you can multiply every measurement by 3 to get your new measurements. So my triangle is going to be 1 times 3 is 3, and 2 times 3 is 6. So I need to draw a triangle that's 3 inches tall and 6 inches wide. Okay, so go ahead and draw your base of 6 inches wide, and then my triangle needs to be 3 inches tall. So we're going to do 3 inches tall. And then you can go ahead and finish off your triangle by connecting the third line. Okay, so your triangle should look something like this. We're going to go ahead and label the height and the width. So the width is 6 inches, and then the height is 3 inches. So notice that your triangles look the same. They're just different sizes. So if you drew a triangle and it doesn't look the same, like maybe it looks like that or something, then that should be a clue that you didn't do it correctly. It needs to look the same other than the size. Now let's use the scale 1 to 2. This means that every 1 that you draw represents 2 on the original. The scale factor is 1/2. And you can do that by creating a fraction out of those, 1/2. Draw the scale triangle below. So that means I'm going to multiply everything by 1/2 because every 2 on the original is 1 that I draw. So let's go back up to my figure up here and we'll write the new dimensions. Okay, so for every 2 on the original, like right here, every 2 on the original, I'm going to draw 1. So I'm going to divide it in half, and that gives me 1, and this one's going to become 1/2. So I need to draw a triangle that's 1 inch long and 1/2 inch tall. So go ahead and get your ruler set up. So there's my 1/2 inch tall, and now I need to do 1 inch wide. Then go ahead and connect your triangle to finish it off. All right, so again, your triangle should look like the other triangles. It's just smaller, but it looks the same. And we need to label my dimensions. So this is going to be 1/2 inch, and then this is going to be 1 inch. So just a really quick review here with my scale factor. If my units are the same, my scale factor is going to be this right here, my scale as a fraction. So like 3:1, or down here, 1:2, and that's my scale factor. I can just multiply every number in my scale by the scale factor to get my new dimensions. And that's another way of doing it if my units are the same and I can get the scale factor. So I can always set up proportions, but if I want to use my scale factor, I can do that as well. I'm going to use my scale factor in this case. It says use a scale 3:2 to scale this trapezoid. So that means my scale factor is going to be 3:2 or the same as 1.5. So I can multiply every length in my original here to get my actual drawing, and that's going to be the size of it. First, it says label the dimensions of the vertical height and the 2 parallel bases. So the vertical height right here, and then my 2 bases, I'm going to need to measure that. So if you get out your ruler, the first base, it looks like it's 2 inches, and I'll just go ahead and measure this base right here. That looks like it's 1 inch. By the way, you can see that this top thing right here is centered right here. So this distance right here is going to just be right in the middle. So this distance right here is going to have to be 1/2 inch because it's in the middle. Okay, now let's measure the vertical height. Okay, and it looks like my vertical height is also 2 inches. All right, so I'm going to write the dimensions of my trapezoid first, and then I'm going to draw it. I've already figured out that my scale factor is 1.5, so I need to multiply all the dimensions by 1.5 to get me the new dimensions. So 1 inch times 1.5, that length right there is going to be 1.5 inches. My 2 inches times 2 times 1.5 is going to give me 3 inches. And then same thing right there, my vertical height is 3 inches. And then this 1/2, that will just help me to make sure that it's in the middle. That's going to become 0.75 inches. I'm going to start by drawing my base here on the bottom. There's my base, and you can see that I kind of marked my 0.75. That just helps me know where the middle is. And now I'm going to need to do my vertical height next, so I can figure out where to put my top base. And so that needs to be 3 inches. So I'm just going to put a little mark there at 3 inches. Then I'm going to go ahead and turn my ruler and do a 2-inch base there at the top. And if you see, I'm going to line the beginning up right there with where I marked 0.75 to make sure that it's exactly in the middle. Oh, and I think I said it's a 2-inch base at the top, but it's a 1.5-inch base. There's my top base, and I'm just going to go ahead and connect the rest of the trapezoid to finish it off. Okay, so just a quick check. My trapezoid should look the same, different sizes, yes, but it should have the same look to it. So there's my trapezoid that I just created. And I'm going to go ahead and label the base's height. So we have 3 inches here, 1.5 inch at the top, and then this height right here is going to be 3 inches. Okay, last one. It says scale the same given trapezoid using a scale of 1 to 4. So my scale factor, I'll just do SF, is going to be 1/4. So I'm going to multiply every dimension by 1/4. I've erased the dimensions of my previous problem so I don't get confused here. So every dimension by 1/4. So 1 inch will become 1/4 inch. 2 times 1/4, that's going to become 1/2 inch. Same thing with my vertical height. It's going to become a 1/2 inch. And then this distance right here is going to become 1/8 of an inch. All right, so I'm going to draw my base first. So my bottom base is going to be 1/2 inch. And I'm going to mark 1/8 right here and 1/8 right there. So it tells me where the middle is. All right, let's do my vertical height next. And that's going to be 1/2 inch. So the top of my trapezoid is going to be right here. Again, I'm lining my beginning up with my mark that I made down there. And so we have 1/4 inch here at the top. 1/4 inch. And then I'm going to go ahead and finish off my trapezoid by connecting the ends. Okay, so again, your trapezoid should look the same. It should just be a different size. And we're going to go ahead and label dimensions here. So 0.5, 0.25, and 0.5. Okay, everybody, that's it for today. Thank you.